Hello everyone, did you know that some material also can possess their memory? This material called as shape memory alloy or SMA. This metal was found in early 1932 and widely used in 1971. They have three major bases in this system, which is nickel, cuprum, and ferrum. Shape memory alloy is material that can memorize its original shape while heating, which is it has the properties include their pseudo-elasticity and shape memory effect. Pseudo-elasticity is the property which occurs due to the change in crystalline structure, while shape memory effect has two types, which is one-way shape memory effect and two-way shape memory effect. One-way shape memory effect can back to its original shape by heating, while two-way shape memory effect can turn its original shape by heating and cooling for the second shape. To understand what exactly happens when SMA is heated, we need to know some more basics. The structure begins with austenite phase, twine martensite, and detwine martensite. Austenite is a crystalline structure that exists at high temperature and cannot be easily deformed, while martensite is a soft crystalline structure that exists at low temperature and it can be easily deformed. Shape memory alloys always used in industry because of their superior thermomechanical properties. In manufacturing process of shape memory alloy had several methods to achieve shape memory effect due to the ability to get austenitic and martenitic structure by stressing or changing temperature. The two methods of casting or powder metallurgy could involve in specific processing techniques and followed by other mechanical process such as fogging, swagging, and rolling, which is very important in setting nitinol shape. As for casting process, they have three specifically techniques, which is vacuum induction melting, VIM, vacuum arc melting, VAM, and electron beam melting, EBM. They use high purity raw materials for melting due to the presence of impurities and non-metallic elements that may have a significant impact on homogeneity of the alloy. In other methods, the alloy produced via powder metallurgical methods. In this process, the mixture of nickel and titanium pure powders, which is the pre-alloy, were pressed and heated to the low temperatures, which is lower than the melting point of the batch. In addition, the development of intermetallic process, which is normally exothermic, raises the system temperature that triggers the occurrence of eutectic and peritectic process and melting of the batch, which is it will increase the system homogenization. In powder metallurgical methods, they have three basic steps. First, powder blending, malt compaction, and sintering in furnace. This method was derived as fundamental benefits such as a good composition homogeneity through the material compared to those acquired via vacuum melting techniques and the crucial property for biocompatibility of alloy production in biomedical application. In terms of specific techniques that consumed in producing the alloys, it can be divided into two categories, which is the first one is conventional process and the second is rapid or additive manufacturing process. The last type of processing shape memory alloy is forming. Forming SMA can be divided into more operations that consist in melting, casting, hot swagging, cool rolling, and drawing. All of the processing process were conducted inside the industry lab. Therefore, they have many specific techniques in certain temperature to produce the shape memory alloy effect and properties for performing in their applications.
Hi, Assalamualaikum warahmatullahi wabarakatuh. In this part, I will share about applications of shape memory alloys in neurosurgical field, vascular field, aerospace field, and structural engineering. Firstly, application in the neurosurgical field, which device that has been produced is coils, stents, and microgut wires. Coils is used for the treatment of cerebral aneurysm, which localize dilations of the intracranial arteries. Stent used for the treatment of intracranial atherosclerotic disease, while microgut wires is used for stent positioning to obtain a high strain recovery and torsion resistance, which can reduce the guide wire bending problems. Next, application in the vascular field. The device that has been produced in this field is inferior vena cava filter, which has length 25 mm. It is to prevent embolic in patients unable to tolerate anticoagulants. It is used to catch and stop fatal clots from reaching the heart. So here is how the device works.
It shows that the SMA expands like this while heating.
Next, application in the aerospace field, which is device produces morphing wing and planes. It is to increase speed, reduce power consumption, roll control, and temperature. Here is how the wings work.
The alloy can replace the complex system in wings by heating up the electric wire.
Last but not least, the application in the structural engineering, which is damping prevention devices. with conventional devices, including steel cables, runners, and steel rods. Lastly, the shape memory alloys do provide us a wide variety of alloys that can be used in any field. That's all. Thank you.